In this problem, we're asked to verify a general solution of a first-order differential equation. So here's my differential equation. It says y prime equals y sine x. Here's my proposed solution, y equals c e to the negative cosine x. And what do I mean by verifying it by running it through the equation? This is how you verify general solutions. You just show me that it satisfies the differential equation. So that's going to involve first just differentiating it. So find y prime. And when I differentiate with respect to x, I get e to the negative cosine x, just another copy of that function, but the chain rule says now I have to multiply by the derivative of negative cosine x, which is positive sine x. And then I realize, aha, c e to the negative cosine x is just y, so I'm done. I just showed that y prime is equal to y sine x. Part B, apply the initial condition y of pi equals 1 and write down the particular solution. So when I replace x with pi, I'm supposed to get a 1 for y. So just plugging that in, 1 for y equals c e to the negative cosine pi. This condition is going to allow us to find out a numerical value on c. The cosine of pi is negative 1, and the negative of that is positive 1. So I end up with ce to the 1, in other words, ce. I solve for c by dividing by e on both sides. C is 1 over e. Now I can write my particular solution, yp is equal to 1 over e times e to the negative cosine x. And we're done, but we might be able to express this in a nicer way. So I can write 1 over e as e to the negative 1. And then I realize that I can just add the exponents here and end up with e to the negative 1 minus cosine x as my particular solution. So this particular solution, like any particular solution, satisfies the original differential equation, so you could show that it works in here, but it also passes through this particular point. So when x is pi, y is 1.